Welcome back. Critical thinking and challenging question IGCSE level physics, and it is the video 4, a part 4. So let's start our discussion. What are the questions I have? Here the first question I have selected from the atmospheric pressure. It is a barometer, and the barometer is the instrument to measure the atmospheric pressure. At the sea level, the atmospheric pressure is almost 100,000 Pascal. 1 times 10 to the power 5 Pascal. 1 times 10 to the power 5 Newton per meter square. These are all the units of pressure. And this barometer, how do they calculate this 100,000 Pascal? They will measure the height from the surface of mercury in the bowl to the top surface of the mercury in the gas tube. This height might be 76 centimeter, 75, 74 centimeters. It varies. It depends on the altitude. If it is in the sea level, it will have the maximum value of 100,000 approximately. That is 103360 Pascal actually. But and for the calculation, easy calculation, we always take 100,000 Pascal. If we go to the mountain, atmospheric pressure will reduce. So what happened, this level, the height level will go down slightly down. So it might be 75, 74, 73. What is the formula to calculate pressure? Atmospheric pressure is equal to mgh. So sorry, rho gh. Density multiplied by g value multiplied by the height. So the density here, whatever the liquid we have, normally we have the mercury because it is the denser liquid. So the height column, 76 centimeters is enough. If we use water, suppose if you want to use a water as a barometric liquid, here we take 1 meter glass tube is enough because the density is 13,600. For the water density is 1000 kilogram per meter cube. So you will need more than 13-meter glass tube, which is really very tall. And then you need a ladder to check the measurement to see the top level. So that's what we are not using water or any other liquid. We need really very big value for the density so we can reduce the height column. So here the height column 76 is enough. The maximum 76 centimeter or 760 millimeter is enough. So we have taken 1000 millimeter or 100 centimeter or 1 meter glass tube, the length of glass tube. I hope you understood the concept, right? Okay. So this is not the concept here. The concept is something different. Okay. Now we read the question. Some air is trapped in the space above the mercury barometer. Normally here it has to be vacuum. So what if there is some air? What will happen? Will we get the accurate measurement of atmospheric pressure if there is some air? No, we cannot get. What is the reason? Because these air molecules inside the test tube, the glass tube, will create the pressure. It moves randomly, rapidly, and hit inner walls and the surface of mercury here. So force acting per unit area causes pressure. So here this pressure will push the liquid down. So automatically this level 76 centimeter will go down like 74, 73. It is up to the air inside, the how much air is inside. So we should not have air into it. But unfortunately some air is trapped here. So there is a pressure. So what is the question? The glass tube is pressed down. Now we are pressing this glass tube down. When we press this glass down, what happens? Which of the following best describes The change of length, which means the length of air column which is trapped into the glass tube, and the height of the air column, height of the height of air column, and h the height of mercury column. Sorry, the L is the height of air column and h is the height of the mercury column. So what will happen if I press this glass tube downwards? So what happens here, as you are pressing it down, this height, the length, air column length is decreasing. So what happens? Volume of the space for the air decreases, pressure increases according to Boyle's law. The volume is inversely proportional to the pressure. As the volume length decreases, which means the volume, the space decreases, pressure increases. So it will hit more. It will hit the mercury more because more pressure is exerted. As a result, the mercury column will go down. So both the length of the air column decreases, at the same time the height column decreases, the height of the mercury column decreases because of the excess of pressure exerted onto the surface of mercury. So the option is C. Okay, then go to the next question. So the second question, the bulb of a mercury thermometer is first placed in melting ice. Here we have a liquid in glass thermometer. You know, the liquid in glass thermometer has some bulb, and inside there is a thread or a bore, we say, and in the bulb we have a mercury, and when it is heated, the mercury expands and move up towards the bore and will show the reading. Now initially what we have to do to measure, just we have to calibrate. First we have to calibrate. How to calibrate? What is the calibration? First, to place it in the melting ice. We place it in the melting ice at a standard atmospheric pressure, then in steam. Then later we place the thermometer in the steam above the water, the boiling water, which means it has a steam. And finally, we place the thermometer in a liquid X. We don't know the temperature of the liquid X. The length of the mercury thread in the uniform tube above the bulb are 20 centimeter, 170 millimeter, 170 millimeter and 65 millimeter respectively. What it is mean? When you place it into the melting ice, the mercury level rises. The mercury level from the bulb, it rises somewhere here 20 millimeter. When you place it into the above the boiling water, which means steam, it raised up to 170 millimeter. And we place the same thermometer in some liquid. We don't know the temperature of liquid. It reaches 65 millimeter. The mercury rises from here to here. Okay, now we have to find what is the temperature of liquid X. Here we have the formula and we have the logic. So first I will teach the logic, how to find the logical way. So initially the 20 millimeter is located at 0 degrees Celsius and 170 millimeter is located at 100 degrees Celsius. So what is the temperature difference here? 100 minus 0 is 100 degrees Celsius is the temperature difference. What is the length in between? The total length in between 0 to 100? 170 minus 20, which means 150. Divisions are there. 150 millimeter, the length is 150 millimeter for 100 degrees Celsius. Okay, now I want to find the temperature at the height of 65 millimeter. So what is the difference we have to find? The difference is here 65 minus 20 will be 45. So right here 45 millimeter, sorry, here we have to write for 45 millimeter what is the temperature X. Then later we cross multiply this. So when we cross multiply 150x is equal to 100 times 45. Cross multiply this and we divide 100 multiplied by 45 over 150. So here we can cancel this one 2 times, this 3 times. So 90 over 3 will be 30 degrees Celsius. So the liquid X, the temperature of liquid X is 30 degrees Celsius. This is the logic way. And we can use the formula. The formula to find unknown temperature is L theta minus L0 over L100 minus L0 multiplied by 100. This is the unknown temperature X is equal to. So all the informations are here. L theta means the length of mercury column when you place the thermometer in the liquid. What is the length? 65 millimeter. Now everything we calculate from the bulb. We are not subtracting. Here this is starting from 0 and here is 170. So 0 to 170. So L theta means this length from the bulb to this length is 65 minus L0 from the bulb to the 0 degree Celsius, that is 20 millimeter, divided by L100 is 170 minus L0 again 20 multiply by 100. So here is 45 and here is 150 and here is 100. So you will get 30 degrees Celsius. Hope you understand this. And let's see the next question. Which topic is this? So here is the question number 3. A sealed test tube contains a gas. Here a test tube is sealed, which means the air inside the test tube or the gas inside the test tube is constant, which means no gas escape or no gas get in, and it is at atmospheric pressure and room temperature also. Room temperature, which means the temperature is constant. It is then placed in a container filled with ice. When you place the sealed test tube, in the container filled with ice cubes, what happens now? What happens? The temperature, the heat energy will transfer from hot to cold. So here the gas releases its heat energy to the ice. So the temperature of gas decreases. So what happened to the movement? Movement of gas decreases, which means average speed of the molecule decreases. So they are asking what is the incorrect option. So this option is correct. Average speed will decrease, right? Molecules, because the temperature is releasing. The gas temperature is released. The average distance between the molecule decreases. So this average distance, the distance will not increase or decrease if it is sealed. It will not increase or decrease as long as we change the volume. We change the volume. So this is the option, right option. This is incorrect. And read the next. Average kinetic energy of the molecule decreases. Yeah, speed decreases means automatically the kinetic energy of the molecule decreases. So this is the right option. It's not incorrect. It is a correct option. The molecules collide less often, which means the pressure decreases, right? Speed decreases which means the collision between the molecules and collision with the walls of the container, walls of the test tube decreases. So this also right option. So our answer is B. The distance between the molecules will not decrease even though it is cooled, because the test tube is sealed. This is the keyword for us. Hope you understand the question, right? The concept. Okay, next concept, let's see. So here is the another question, number 4. Air is trapped in a capillary tube by a thread of mercury 5 centimeter in length. So here is a capillary tube, and air is trapped here in this side at the bottom of mercury 5 centimeter length. When placed in the two position as shown in the diagram 1 and 2, the lengths of the air column are recorded as 35 centimeter and x centimeter. This length here 35 centimeter when it is in the vertical position. When it is in the horizontal position, the length we don't know, unknown, x centimeter, and the length of the mercury is here 5 centimeter. So which of the following statements about x and the pressure of trapped air in the diagram 1, P1, here the trapped air has the pressure P1, and the pressure trapped in air diagram 2, P2, here the pressure is P2. So we have to find the right option. What is the value of pressure and what is the length of x here when it is in the horizontal position? Okay. So what is the concept here? The mercury has some weight which is acting down onto the air molecules. As the air molecules are being pushed by the mercury, 5 centimeter length of mercury, the molecules gaining pressure. As it is going down, it is being the air molecules are being pushed and the volume decreases, pressure increases. As it develops pressure higher and higher and higher, finally the molecule, the mercury moving down is stopped and balanced by the pressure developed by the gas molecules or the air molecules here, the trapped air molecules. So it will stop the mercury goes down. Okay. So at this point it has the pressure, this pressure is P1. So what will happen if the capillary tube is placed in the horizontal position? When it is placed in the horizontal position, the mercury weight will not act horizontally. The weight will not act horizontally, never act horizontally. It always acts vertical. So here the factor of weight is not acting onto the air molecules. So the air molecule has the pressure will push the mercury away to the right side. So it will take extra space, it will take a more volume, the air will take more volume as it push the mercury away to the right side. So here it has the more volume here, so the pressure will be less. The P2 pressure is less than P1. At the same time, as it takes more length, so the length of x is greater than 35 centimeter. So what is the option here? X is greater than 35 and P2, the pressure P2 at this point is less as it takes up more space. So the option is B. So next question is a very interesting question. It is about light. A point source of light is placed 3 centimeter above a plane mirror. So here is the plane mirror and here is a source and it is 3 centimeter above. It is its reflected ray is detected 2 centimeter above the mirror at a horizontal displacement of 12 centimeter. So the horizontal displacement is 12 centimeter, and here is the detector which can detect the light from the source like this. So here the question is the distance between A and the point of incidence is. We have to find the distance. For example, here is a light ray like this example. So this is the incident ray, here is the reflected ray. I want to find this length from A to the point of incidence. Here this length is unknown because there is no clue here, because they did not give you the angle of incidence, angle of reflection, no clue, just 3 centimeter, here 2 centimeter, 12 centimeter, and we have to find this length. So it seems like the similar triangle. So in the concept, if you know the concept of similar triangle, we can easily solve this problem. What similar triangle? This 3 centimeter, this length proportional to the small triangles 2 centimeter. These are all the proportionally increase and decrease. So we write the bigger length and the small triangles length, the height 2 is equal to, now we have to write the base. The bigger triangle base is here, this length that we have to find. So the total length is 12. So this point we can give x. From here to here we give the length is unknown, we can give x. This length is x. So write it on the top. Divided by, what is this length? This length is the total length minus x. So total length 12, and we reduce this value x. So we write here this value 12 minus x. Now what we can do? We can cross multiply. So 2 times x is 2x, then 3 times 12 minus x. Now we expand 36 minus 3x. Now take this 3x to the left side. So 3 plus 2 will be 5x is equal to 36. So x is equal to 36 divided by 5, 7.2 centimeter. So the option is here, C. C is the option. So here, more than physics, we need to know the mathematical knowledge. So then we can crack the question easily. So now we understand the point of incidence, the length of point of incidence from A is 7.2 centimeter. So it is interesting question, isn't it? Yeah, and then next video we can discuss some more interesting concepts and knowledge. We can gain more knowledge. So keep watching my videos for extra knowledge to crack your O-level examination, to get the A star report or the brilliancy, to get the brilliance award. So keep watching. I will collect very interesting, critical and challenging questions, and we can discuss and then wait for the next video. Thank you very much for watching my video. Bye bye.